Imagine a place where the sky is perpetually cloaked in thick sulfuric clouds, a world where temperatures soar to a blistering 475 degrees Celsius. This is Venus, Earth's twisted sister, a planet that mirrors our own in size and composition, but tells a dark tale of solar affection gone disastrously wrong. The very name Venus conjures images of beauty and love, but in reality, this planet is a hellscape of unimaginable extremes. Venus, often called the evening star, shines brightly in our night sky, a beacon of light that masks the horrors lurking beneath its dense atmosphere. Unlike the serene, life-supporting climate of Earth, Venus's surface is a vision from a nightmare, dominated by crushing pressures and relentless heat. The thick blanket of carbon dioxide that envelops the planet traps heat in a runaway greenhouse effect, creating a world where metal melts and life, as we know it, cannot survive. The fascination with Venus is not new. Astronomers and scientists have long been drawn to its deceptive allure. Early telescopes revealed little more than a bright, featureless disk, leaving much to the imagination. But as technology advanced, so did our understanding, and the reality uncovered was far more terrifying than any fiction. Venus is a planet that serves as a dire warning, a glimpse into a possible future if we fail to heed the lessons it offers. Venus's tale is a harrowing one, a story of solar affection turned deadly. Its conditions are not just extreme, they are apocalyptic. As we delve deeper into the scientific underpinnings of this celestial inferno, the true extent of Venus's hostility becomes even more apparent, casting a shadow over our own planet's future. To understand why Venus is so hot, one must delve into the science of its atmosphere. The planet's thick, toxic blanket is composed almost entirely of carbon dioxide, with clouds of sulfuric acid perpetually swirling above. These conditions set the stage for the runaway greenhouse effect. The concept of the greenhouse effect is simple yet profound. On Venus, this process has gone into overdrive. The thick clouds of carbon dioxide trap the heat so effectively that temperatures rise to more than 475 degrees Celsius. The surface of Venus is a testament to the power of this effect. With temperatures that never drop below the boiling point of water, Venus is a world in thermal equilibrium. This hellish environment poses significant challenges for any potential exploration. Yet understanding Venus is crucial for insights into the future of Earth's own climate. The runaway greenhouse effect is the first key to unlocking the mystery of Venus's extreme temperatures. It is a phenomenon that occurs when a planet's atmosphere traps heat in a vicious, self-reinforcing cycle. On Venus, this cycle is driven primarily by carbon dioxide, a potent greenhouse gas. In stark contrast to Earth, where the greenhouse effect maintains a delicate balance necessary for life, Venus's atmosphere has spiraled out of control. Imagine a world where every ray of sunlight that breaks through the dense cloudy shroud is trapped and held prisoner by the atmosphere. This is Venus. The sunlight penetrates the thick clouds, heating the surface. However, instead of this heat being radiated back into space, it is absorbed and re-radiated by the carbon dioxide, further heating the atmosphere. This process repeats endlessly, creating an environment of unrelenting heat. The consequences are catastrophic. Unlike Earth, where carbon dioxide levels are regulated by natural processes like photosynthesis and the carbon cycle, Venus has no such regulatory mechanisms. The planet's volcanic activity spews massive amounts of carbon dioxide into the atmosphere, exacerbating the greenhouse effect. Over time, this has led to temperatures that are consistently above 475 degrees Celsius, making Venus the hottest planet in the solar system. Understanding the runaway greenhouse effect on Venus is not just about knowing why it is so hot. It serves as a stark warning. It illustrates what could happen if Earth's delicate atmospheric balance were to be disrupted. Venus's story is a cautionary tale of how a planet can transform into a hellish inferno if the greenhouse effect runs unchecked, highlighting the importance of maintaining our own planet's climate systems. Beyond the runaway greenhouse effect, the composition and density of Venus's atmosphere play critical roles in its extreme heat. Venus's atmosphere is composed of 96.5% carbon dioxide, with the remaining 3.5% made up of nitrogen and trace amounts of other gases. This high concentration of carbon dioxide is the primary driver of the planet's extreme greenhouse effect. The density of Venus's atmosphere is another critical factor. It is so thick and heavy that the pressure at the surface is equivalent to being 900 meters underwater on Earth. This immense pressure contributes to the planet's extreme temperatures by preventing heat from escaping, The atmosphere acts like a pressure cooker, trapping and amplifying the heat generated by the greenhouse effect. Moreover, the presence of sulfuric acid clouds adds another layer of complexity. These clouds reflect sunlight, creating a paradoxical effect. While they prevent some solar radiation from reaching the surface, they also contribute to the greenhouse effect by trapping infrared radiation. This combination of reflective and trapping properties creates a thermal blanket, maintaining the planet's scorching temperatures. Understanding the atmospheric composition and density of Venus is essential for comprehending why the planet is so inhospitable. It highlights the delicate interplay between atmospheric components and climate, offering insights into how changes in atmospheric composition can lead to dramatic shifts in a planet's climate. For Earth, this underscores the importance of monitoring and managing greenhouse gas emissions to prevent a similar fate. Venus's surface temperatures and pressures are nothing short of nightmarish. The planet's surface temperature is a constant 475 degrees Celsius, day or night, equator or pole. This extreme heat is sufficient to melt lead, zinc, and many other metals, creating a landscape that is both molten and hostile. The planet's slow rotation means that its surface is exposed to the sun for prolonged periods, baking it relentlessly. The surface pressure on Venus is equally daunting. At 92 times the pressure of Earth's sea level, it is equivalent to the pressure found nearly a kilometer deep in Earth's oceans. This crushing pressure means that any spacecraft or equipment sent to Venus must be built to withstand immense forces, adding to the challenges of exploration and study. Such extreme conditions have profound implications for potential missions. Historical missions, such as the Soviet Venera series, have shown that even the most robust technology can only survive for a short time. The Venera landers, designed to endure the harsh environment, managed to send back data for mere minutes before being overwhelmed. This highlights the need for advanced materials and technology to explore Venus's surface effectively. The relentless heat and pressure of Venus's surface provide a stark contrast to the relatively mild conditions on Earth. They serve as a reminder of the extremes that exist within our solar system and the challenges that lie ahead for humanity's quest to explore and understand these alien worlds. It also poses a question: what can we learn from these extremes to better protect our own planet? Solar radiation plays a crucial role in Venus's extreme climate. Venus is closer to the sun than Earth, receiving about twice as much solar energy. The thick, toxic atmosphere of Venus acts like a giant thermal blanket, trapping most of the incoming solar radiation. Venus's clouds, composed of sulfuric acid, reflect a significant portion of the incoming solar radiation. While the clouds reflect sunlight, the carbon dioxide traps infrared radiation, increasing temperature. Studying Venus helps us understand climate shifts and the importance of protecting Earth's balance. The Soviet Venera missions hold a unique place in space exploration, being the first to land on and transmit data from Venus's surface. They faced the challenge of Venus's hellish conditions. Venera 7 in 1970 was the first to transmit data from another planet's surface. Venera 9 and 10 sent back the first images of Venus's terrain. Venera 13 and 14 provided panoramic images and soil analysis in 1982. They confirmed Venus's extreme conditions, with temperatures around 475 degrees C. The Venera missions showcased courage and innovation in space exploration. While the Venera missions provided the first glimpses of Venus's surface, NASA's Magellan mission, launched in 1989, aimed to map the planet in unprecedented detail. Unlike the Venera landers, Magellan used radar to penetrate the thick clouds and produce high-resolution images of Venus's surface features. This mission marked a significant leap in our understanding of Venus's geology and topography. Magellan was an ambitious mission that orbited Venus from 1990 to 1994, using synthetic aperture radar to map 98% of the planet's surface. The data revealed a landscape dominated by volcanic features, including vast lava plains, huge shield volcanoes, and complex tectonic structures. One of the most striking findings was the presence of large corona circular regions formed by upwelling of molten rock. These features provided evidence of the planet's active volcanic history. The radar images also highlighted the absence of plate tectonics, a key process that shapes Earth's surface. Instead, Venus's crust appears to be a single, continuous plate that periodically undergoes catastrophic resurfacing events. These events erase much of the planet's geological history, making it a challenge to piece together its past. The lack of water on Venus is believed to be a significant factor in this difference, as water plays a crucial role in Earth's plate tectonics. Magellan's mission was a resounding success, providing a wealth of information that continues to be studied by scientists today. The radar maps it produced allowed researchers to analyze Venus's surface in detail, leading to new theories about its geological processes and history. This mission underscored the importance of remote sensing in planetary exploration, particularly for planets with thick, impenetrable atmospheres like Venus. As our understanding of Venus deepens, so does the ambition of future missions. Several new ventures aim to uncover more about this mysterious planet. One of the most anticipated is NASA's Veritas mission. Veritas will produce high-resolution topographic maps of Venus's surface. ESA's Envision will complement Veritas by focusing on Venus's atmosphere and surface composition. India's ISRO has proposed the Shukrayan-1 mission to study Venus's surface and atmosphere. These missions promise to unlock more secrets of Venus, revealing the planet's past. Exploring Venus presents unique technological challenges due to its extreme conditions. Innovations in material science and engineering are critical to overcoming these obstacles. Researchers are exploring new heat-resistant materials and cooling systems to protect sensitive electronics. Advances in communication technology and autonomous systems are essential for reliable data transmission. Venus stands as a stark contrast to our own blue planet. While Earth supports life, Venus's atmosphere is a cauldron of toxicity and heat. Earth's water cycle contrasts with Venus's sulfuric acid rains, which evaporate before reaching the ground. Studying Venus highlights the delicate balance required to maintain a habitable world. Venus teaches us a crucial lesson about the fragility of planetary climates. The runaway greenhouse effect on Venus serves as a dire warning for Earth. Human activities increasing greenhouse gases mimic the process that doomed Venus. Addressing climate change is urgent to prevent catastrophic outcomes. The possibility that Earth could follow Venus's fiery path is a topic of intense speculation. Rising carbon dioxide levels could trigger feedback loops that amplify warming. Earth's dynamic climate systems and human intervention offer hope. Understanding Venus helps us take steps to preserve Earth's habitability. Exploring Venus is about learning lessons crucial for space exploration and Earth's survival. Innovations for Venus missions can enhance our ability to explore other harsh environments. Venus's history reminds us of the importance of planetary stewardship. International collaboration in space science is vital for tackling global challenges. Venus serves as both a cautionary tale and a source of invaluable knowledge. The runaway greenhouse effect on Venus warns about the fragility of planetary atmospheres. Venus's extreme environment underscores the importance of robust planetary protection strategies. Studying Venus helps refine models of planetary evolution and predict climate change impacts on Earth. The exploration of Venus holds vital significance for the future of space exploration. Technological advancements for Venus missions enhance our capability to explore other harsh environments. International collaboration in space research is crucial for tackling challenges. Understanding Venus helps prepare for the unexpected challenges of space colonization. Venus's climate serves as a chilling reminder of Earth's potential future. Rising greenhouse gas levels on Earth echo the processes that led Venus to its current state. Addressing climate change is urgent to prevent catastrophic outcomes. The knowledge gained from Venus inspires proactive measures for a sustainable future. Venus challenges our perceptions and expands our knowledge of the cosmos. The pursuit of knowledge about Venus drives technological advancements and international collaboration. Venus's journey offers a mirror, reflecting potential paths for Earth. Let us carry the lessons of Venus, striving to protect our planet and explore the unknown.